3i Atlas is delivering exactly what scientists have hoped for. New data, new wavelengths, and new clues, all right on schedule for its December 19th Earth debut. But this was supposed to be just another red, frozen wanderer, until two astronomers caught it turning green under a blood moon. What could make a comet shift color as it races closer to Earth? The answer could rewrite everything we know about interstellar chemistry. September 7th, 2025. Under the shadow of a total lunar eclipse in Namibia, two seasoned Austrian astronomers, Michael Jaeger and Gerald Riemann, tracked an object that had only recently arrived from beyond our solar system. For weeks, Comet 3i Atlas had glowed a deep, dusty red, its color shaped by sunlit surface dust and ancient organics. But through their telescopes that night, a new hue began to appear. Their images captured a gas-rich coma spanning 2 arc minutes, shining green with a faint blue edge against the blood-red glow of the eclipsed moon. This was more than a trick of the atmosphere or camera, filters confirmed the color. In a single night, the comet's reputation shifted from just another interstellar visitor to a scientific anomaly. The Namibia eclipse images became the baseline, the first clear evidence that 3i Atlas was changing, and that something extraordinary was happening inside its icy core. On November 26, 2025, the Gemini North Telescope on Mauna Kea delivered the first high-resolution confirmation of what amateur astronomers in Namibia had suspected for months. Using the Gemini multi-object spectrograph, scientists captured a set of images through blue, green, orange, and red filters. Each exposure tracked the comet itself, causing background stars to streak across the frame, while the nucleus remained sharp at the center. The result was a faint but unmistakable greenish glow in the coma, clearly visible in the green filter and absent just weeks earlier in Southern Hemisphere images. This was not a camera trick or a quirk of the atmosphere. The green emission lined up with the spectral fingerprint of diatomic carbon, a molecule known to glow under sunlight in the vacuum of space. Gemini data ruled out artifacts and confirmed that 3i Atlas was venting fresh gases as it neared the sun, setting a new scientific baseline for activity and composition. Subscribe for updates on this story and more on the dramatic transformation. By late November, astronomers tracking 3i Atlas noticed more than just a color change. The comet's activity was ramping up. The gas-rich coma, first measured at 2 arc minutes across during the Namibian eclipse, continued to swell as the weeks passed. Observers using both backyard telescopes and professional instruments reported a steady brightening, with the green glow around the nucleus becoming increasingly prominent. Time series photometry from amateur networks and observatories worldwide charted a clear upward trend, suggesting that solar heating was driving more volatile material to the surface. The coma's expansion and intensified color pointed to a rising gas-to-dust ratio, a sign that the comet was venting fresh ices from deeper layers. This acceleration in brightness and activity set the stage for possible outbursts, as delayed heat from the sun could trigger sudden releases of gas and dust. Scientists watched closely, knowing that each new spike in brightness could reveal more about the comet's hidden interior. After passing closest to the sun on October 29th, 3i Atlas began to behave in ways that caught even seasoned researchers off guard. Astronomers running thermal models had predicted a delay between the sun's heat striking the surface and the deep interior starting to react. That delay is now playing out in real time. As the comet reappeared from behind the sun in early December, its activity surged. The green glow intensified, and the coma grew, evidence that solar energy was finally reaching pockets of buried ice and volatile chemicals. This lag in heating means the days just after perihelion are the most volatile. Prime time for sudden jets or outbursts as new layers are exposed. Each night brings the possibility of a dramatic event, and telescopes worldwide are watching for any sign that the comet's core is venting even more material into space. With just 5 days until its closest approach, a global network of telescopes and space missions is locked onto 3i Atlas. Teams from NASA, the European Space Agency, and observatories around the world are running around-the-clock observation campaigns, watching for any sign of a sudden outburst or chemical spike. Spectroscopy instruments are on standby, ready to capture the comet's secrets if the core vents fresh material. Every night could bring a breakthrough as astronomers race to see if this interstellar visitor will surprise us again before it slips away. Right now, 3i Atlas reveals chemistry untouched since another star. Each new glow changes what we know about our origins. This is interstellar science, happening live, right above us. 3i Atlas is doing something new in all of human history. It is giving us an opportunity to study an object which is a piece of another solar system, all without leaving Earth. Subscribe now for more discoveries.